Sir, good morning, sir. Joshi Manohar, sir.
Sir, good morning, sir.
Sir, once again, welcome, sir.
Thank you, sir. Thank you, sir.
Sir, this is Miss Jarina, sir, assistant professor. Today he'll be available along with you for the entire session, sir.
Huh? Okay, very good morning, ma'am.
Thank you, sir. Already it's time 10 o'clock, sir. Can you we will start?
Yeah,
sir?
we will start. Right.
Before that, let me take the opportunity.
Good morning, sir.
Very good morning, ma'am.
Thank you, sir. Welcome for today's FDP, sir. Very good morning to all. Myself, I am S. Jarina, working as an assistant professor in the department of CREC College. So, before going to session, let us go the brief profile of Dr. V. Joshi Manohar, sir. So, it's a great pleasure for me to introduce Dr. V. Joshi Manohar, sir, our speaker today, who is going to give presentation on soft computing techniques in control of multi-level inverters, a practical approach. Dr. V. Joshi Manohar, sir, earned his doctoral degree in electrical engineering from JNTU Anantapuramu in 2015. Sir did his MTech in power electronics from VTU Belgaum in 2004. He holds his BTech degree from Nagarjuna University, Guntur in 2000. He has about 19 years of teaching experience in engineering colleges and served the institutions at different levels as head of the Department of EEE, Director of R&D and Principal. At present, Sir is working as a HOD of EEE in Presidency University, Bangalore. His technical expertise includes control of multi-level inverters using soft computing techniques, reactive power compensation at low switching frequency using intelligent techniques, control of electric drives using soft computing techniques, design, development, and control of novel multi-level inverter topologies by minimizing number of switches and sources. Sir has published very good number of research papers in different reputed journals and conferences, and also published 3 books. Sir has filed 4 patents as a first author. Sir has played a vital role in establishing MSME Business Incubation Period, Government of India at Presidency University. Sir also acted as a BYS member at BDA College of Engineering, Kalburgi, and BM SIT Bangalore. Sir has citations of 30 and H index of 2. Thank you, sir, for being with us for today. Sir, please continue the session, sir.
Thank you so much, ma'am. Thank you so much for your nice introduction. And I have to appreciate the team, particularly HOD sir and the coordinators and the principal sir for organizing this beautiful program. So the way how we have selected the speakers from various sectors, let us say, previously, I think last session I have attended Dr. Ashok Kumar. He is a prominent person in PSD College of Engineering. And I think day after tomorrow, I think Dr. S.N. Deepa ma'am is there. Yes. And she's also one of the prominent person in the field of soft computing techniques, and he has published several books. And from my core of my heart, I would like to appreciate the team for selecting the good resource persons for the event. And thank you very much for giving this opportunity for this session. So with this permission, let me continue my presentation.
Okay.
Shall I share my screen?
Yes, sir.
1 minute. Is it visible, ma'am?
Sir.
Yeah. Right. Good morning, everyone. Welcome to the another session in the series of FDP here. So coming to me, this is Dr. Joshi Manohar, working as HOD and Associate Professor in the Department of Tripoli and Presidency University, Bangalore. Today, I would like to share some few points, or I want to give some sort of bird's eye view on where these soft computing techniques are helpful for us to find some feasible solution, or otherwise some, to solve some complex engineering problems, how these soft computing techniques are helpful for us, that we will see. So let me go to the title for today's session. So that is soft computing techniques in control of multi-level inverters, a practical approach. So anyhow, I think if you see the audience here, we have a mixture of different cognitive levels. So maybe some students will be present, some MTech students may be present, some research scholars may be present, some faculty members may be present. So in order to strike the balance between all the cognitive level of people, so let me give you some sort of bird's eye view on what is the purpose of soft computing techniques, and what is the reason why we have to approach these soft computing techniques for solving some complex problems in engineering. And I would like to give you some sort of insight how to formulate a problem. Suppose if you are doing some sort of a research, so first you have to formulate a problem. In order to formulate a problem, what are the steps that we have to follow? In order to apply the soft computing techniques, how to formulate some function that is called some objective function that we will see. And also we will see how we can, we will take one soft computing technique, let us say the particle swarm optimization technique, which is a simple and best optimization technique. And with help of that optimization technique, we will see how we can control the multi-level inverters. So that means we will see in a practical approach. Ma'am, can you mute everyone so that there should not be any different disturbance in the meeting? Ma'am, can you mute all the participants, ma'am? I can see a lot of disturbance in my ear. Yeah, thank you so much.
Okay.
Right. So that is our today's agenda. Let me go to the another slide here. Coming to the agenda of this webinar, so that is control of multi-level inverters using soft computing techniques or nature-inspired algorithms, a practical approach. So what are the outcomes of this webinar? That means after completion of 1.5 hours of session here, there should be some takeaway points. So my point of interest here is, I don't want to waste your valuable 1.5 hours of time here, but let me give you some sort of, that means a brief overview of how to choose a soft computing technique, how to formulate a problem, how it can be implemented to a one practical, one case that we will see here, an application we will see here. So coming to the outcomes of the webinar, on successful completion of the webinar, the participant shall be able to discuss the role of nature-inspired algorithms or soft computing algorithms in providing the feasible solution to complex engineering problems. So this is the first outcome. So the participant shall be able to discuss the role of nature-inspired algorithms. And the second one is we will list out the components of optimization problem. Suppose if you want to apply any soft computing technique, before that we have to formulate a problem, right? So how to formulate that problem and what are the components are there? This is called objective function. So in order to formulate an objective function, what are the components that we should have, that we will see. Next one is we will take one nature-inspired algorithm or soft computing algorithm that is called a particle swarm optimization technique for solving a single objective optimization problem. And we will take some simple problem, let us say solving some simple equation, how we can implement these particle swarm optimization to find the feasible solution for that we will see. And the next one is able to describe the control of multi-level inverter using the particle sum optimization technique. That means by using this soft computing technique, how we can control a multi-level inverter. So in this multi-level inverter, here we are considering a 3-phase cascade H-bridge 11-level inverter. And let me tell you how we can implement this soft computing technique in order to control one application, let us say in electrical application, how to control this inverter with help of this soft computing technique at a wide range of modulation index that we will see here. And in this case, I told you we will take some numerical example so that we can understand easily how this PSO can be implemented. And some case study I told how to control this chosen multi-level inverter with PSO. So let me brief this agenda once before going to the session. So the first one is, first we will see what is the importance of these soft computing techniques. So because in order to address all cognitive level of people, let me take some simple examples so that everybody can understand and they can have some sort of insight or otherwise some light how to formulate the problem and how to apply the soft computing problem for their own application. Maybe here the application may be inverter control. In your case, it may be some other thing. So, but the structure or the flow, everything will be same, whatever it may be, whatever the problem that you take, the steps that we have to follow is same. So I want to give you some sort of a roadmap to you, how to formulate the things and how to apply these, whatever the algorithm maybe a particle sum optimization, maybe some anticollinear optimization algorithm, maybe some BAT algorithm, whatever it may be. So how it can be implemented for your problem that we will see here. You will get some sort of knowledge about it. So let me brief you once again here. The first one is we'll able to discuss the role of nature-inspired algorithms. Second one is we will list out the components of the problem, because in order to formulate the objective function, there should be some components there. So what are the components? And we will take one algorithm that is called PSO algorithm. And here we're having two parts. So we will see how this algorithm can be implemented with taking some example. And another one is we will take some case study and we will implement this PSO algorithm to control the multi-level inverter. So that is our today's agenda. If you have any queries, you are free to post in the chat box, or otherwise at the end of the session, we have question and answer sessions, then we can discuss there. So you, in the meanwhile, you please note down the points. If you have any doubts or anything, you can note down that one, and we will address all those things at the end of the session. Right. The first one in front of us is, what is the purpose of going for these soft computing techniques or nature-inspired algorithms? That is the first point, because it should be feasible. If there is no need, then it is foolishness to approach these algorithms for solving our problems. While doing research, we should not take the algorithms in a fancy way of approach, because the trend is implementation of so-and-so algorithms. So that is why we have to use these algorithms. It's not like that. The question here is, what is the purpose of choosing these algorithms? Let me tell you the first important purpose, or otherwise the need for approaching these algorithms is, the traditional methods which we are having are unable to find the feasible solutions for complex engineering problems. That is the reason why we are approaching these algorithms. If you want to understand in a little bit in a clear way, let me take you one example. If you see here, let me take you one example here. You can see one kingfisher bird here, and by the side of it, you can see the bullet train which is present in Japan. By the time when this bullet train was introduced, there was a restriction that the decibels that are allowed is only 70 decibels. Previously, these bullet train did not have the shape like this. So whenever this bullet train was entering into the tunnel and coming out of the tunnel, because of the air friction, it is producing a lot of noise. So that noise is much above these 70 decibels, and all the people who were staying surrounding that particular tunnel and everything, they launched some complaint to the government. So the researchers, they started thinking about to find a feasible solution for that problem. So one researcher, on his outage or something like that, he went to some national park, something like that. There he observed how this kingfisher bird is catching its prey. If you see this picture here, this is a kingfisher bird, and who was sitting here and eagerly waiting to catch the prey. The prey may be some fish here. So then what it will do, it will dive into the air and into the water, and it will catch the prey and it will come out. That means the moment when the beak of these kingfisher bird touches the surface of water, it won't even produce a big noise. Otherwise, this fish will move away. That means the noise which is produced by, that means when this beak will touches this water surface, the splash sound will be very, very, very less, in such a way that even the fish could not recognize that sound. So this design he has mimicked in his, in designing these, the shape of this bullet train here. That means the complex problem which is present in our day-to-day applications, the nature has provided some solution, and we are mimicking the design of the nature for our problems. So this type of phenomena is called the nature-inspired algorithms, otherwise biomimicking. So let me tell you another example here also. I think being an electrical engineer, we know this wind turbine here. And if you see the fins of this whale, you have a design like this, some special design like this. So if we have mimicked the same design in the blades of the wind turbine blades, the performance has improved to 40% here, because it will reduce the wing drag. So that means there are several things that we can understand because of these, that means by looking into the nature. Let me tell you another application also here. You can see here, these birds are flying in the space. Usually there will be some big skyscrapers where these, what we can call here, some glasses will be there in big structures. So these birds, they were unable to recognize these mirrors, and usually there will be some sort of collision will happen. Because of that, the structure will get damaged, and also we are losing millions of birds because of that, because the birds were unable to recognize this mirror, because as they are so transparent here. So, but unlike if you see into the nature here, this is a spider is there, and spider is having a spider web here. You can see here some objective is present here because of this spider web. But we never notice that these birds will caught in these spider web. So what is the reason for that? The main reason is whatever the spider web which is doing here, this is visible only, that means what we can call here, this is visible only in the ultraviolet region here. That means these birds are having some extra vision, unlike our human beings. We can see vision up to red to Vibgea region only. But here, if you see here, that this particular spider web can be visible under ultraviolet region. So taking this into consideration, the researchers, they are planning to develop a mirror which can include some sort of a structure inside the mirror where it can be visible under ultraviolet region, so that there will be no damage to the livelihood of these birds. So that means why I am emphasizing all these points, because there are some complex engineering problems where the traditional methods, the intelligence of human beings are unable to find a solution. So before going to our subject, let me tell you the last example. I think we usually having a fear to take some injection. It is a human tendency. I think you know that. So by piercing this one, it will, that means there will be a more pain we are having. So, but the same thing, if you see this small creature which is present in this world, this is a mosquito, we can never even sense some sort of that much of pain which we usually have with this needle. But it will do its own process. It will suck the blood from our body and it will do everything. But if you compare the pain which the needle is giving, it is very much less here in the case of this mosquito nose. So what the interesting fact is, nowadays the researchers, they are manufacturing the painless needles. So here this mosquito is having a different phenomena while sucking the blood. They have two structures. One is in vibrating in nature, and another one is used to suck the blood. One is of vibrating in nature, and another one is to suck the blood. So because of this phenomena, this can it will give less pain to our human being, and it can suck the blood. So our scientists, they are mimicking the process of this particular phenomena in developing the painless needle. So if you see all these examples, it is clearly evident that these problems are very complicated. Our calculus-based approaches, or whatever the methods that we are having, are very difficult to find the solution for these typical problems. But luckily, it is all, our nature itself is a big optimizer. There we're having several solutions. So by taking this as an introduction, several researchers, the way how the birds will catch their prey, the way how the wolves will catch the prey, the way how the honeybees will take that honey. So depending upon the different process, they have developed different algorithms by mimicking their behavior. So if you implement that algorithms to our complex engineering problems, we will find the feasible solutions. So the reason why we are going for these nature optimization, nature inspired algorithms or soft computing algorithms is because of the limitations of existing the numerical methods. Whatever the methods that are available, let us say you want to find some minimization, function minimization. You want to minimize the percentage THD, or otherwise you want to maximize the power in the power flow in the transmission line. So then what you have to do, that means you are approaching some calculus based approaches, let us say Newton-Raphson algorithm. So it will completely works on the basis of the calculus based approach, a derivative approach. So those type of things in some cases will be very difficult to find a solution if the function is in non-linear in nature. So during that cases, we will approach these nature inspired algorithms, and then we will find a solution. That is why in research nowadays, these algorithms are becoming so popular. So that is a reason why I have taken pain to tell you some examples so that it will cultivate some sort of interest in your mind to look into these algorithms. So let me see here, the algorithms imitating process in nature, which are inspired from the nature, is called nature inspired algorithms. Maybe genetic algorithm, survival of the fittest algorithm, which is inspired from the nature, particle swarm optimization algorithm, ant colony optimization, ABC algorithm, gray wolf optimization algorithms. There's several algorithms are there. These are all nature inspired algorithms. So that means the place where our human intelligence fails, we are taking the intelligence from the nature to find the optimal solutions. Suppose if you are doing some sort of research, and if you stuck somewhere to solve some nonlinear problem, where you have a different constraints and everything, then these nature-inspired algorithms may be some sort of what we can call, it will provide some sort of solution to you. It is having some limitations when compared with traditional algorithms. Of course, we have to agree for that, because we cannot find anything ideal in this world. So on that part, the nature-inspired algorithms also having some limitations when compared with the deterministic approaches or heuristic approaches. In spite of that, it is gaining a popularity because of their nature of providing solution to complex engineering problems. Then what for? This is nothing but imitation. We are imitating the process which is present in the nature. For what we have to imitate? To find some optimal solution, to do some sort of optimization. This is a very good word in engineering terms called optimization. Optimization is not a minimum. It is not, it won't give you the minimum thing or maximum thing. It is somewhat optimum thing. If you want to tell, let me tell you an example. What is the length of our nose? Length of our nose is not 2 meters. Neither it is 1 meter also. You see, it is optimal in length. We cannot see a person who is having a 2 meters long nose actually. So that means, that is why I told you the God himself is a good optimizer. Everything is optimized in this world. So what we are doing here is the scientists, some good researchers, they have mimicked the process of this optimization and they found solution to complex engineering problems. Let me tell you in a simple way this word optimization. Finding some shortest route. Let us say let me tell you an example. We all studied in our elementary school education. So as soon as our school is over, we will find the shortest route to go home. So that is how it should be. Suppose when we are going to college in our college days, sometimes we will find the fastest route, that means longest route to go to the college if you don't want to go to the college. So that means the finding out of shortest route or longest route, it is some process of optimization. Let us say in manufacturing industry, let us say you are manufacturing the transformer. The core is there. You have to cut the core. You should not cut the core as you like. You have to use that core. That means, let us say some CRGO sheet is there. So that sheet you have to cut optimally. You should not cut as you like. Then let me tell you an example which is very easy for you to understand. Suppose if you are preparing some sort of donuts in your home, for the donuts you will prepare some sort of a dough here, and then you start cutting that dough with some, let us say some glass, something like that. So this is one process of optimization. You should not cut as you like. Then the total, that means it will be wasted. So this is present in day-to-day human lives here. Similarly, suppose if you are you have some industry, your intention is you should get more cost, that means more profit, and your running cost should be less. So that is how you plan. Suppose if you're running some small house in your home, then you'll see that you have some sort of savings apart from meeting the needs of the home. So this is the reason why I'm giving these simple examples, because the word optimization is not some technical word. It is present in our daily life. If we can get some sort of light on that to solve our problem, engineering problems, it is very easy for us to implement and to find the solution. So the reason why I want to emphasize here, optimization is not minimization, it is not maximization. It is some sort of optimal value, which will provide some feasible solution. So these examples I told, and let me go to another one here. Right, you see here, this is nature-based intelligence. This can be broadly classified into 3 types. One is the nature-inspired algorithms or soft computing techniques, where we are going through our study here. And fuzzy logic systems, I think everybody is familiar with this one, fuzzy logic, and the neural networks here. So we can call this one is one branch of natural-based intelligence, where we are using these nature-inspired algorithms to find the solution. So this is another simple way to understand it. All right. Optimization. This is the word which I told. We optimize in our daily lives, and the nature itself has optimized almost everything. So the main point is optimization is a way of life. So this is a flow cycle of whole process. The nature, we will inspire from the nature. We will think and evaluate the concept. We will inspire from the nature. We will solve some optimization problems. We will design some algorithms because of the nature. So the nature is the best inspirer. So many solutions we will get if you really look into the nature and if you have a mind, open mind to understand it. So let me go to further in our discussion here. So these are algorithms which I told, nature inspired algorithms. The major point that you have to understand here is the nature inspired algorithms, you have a population based search methods here. If you consider here particle swarm optimization technique, you have a group of birds. Here a group of ants will be there. So bee colony algorithm, you have a group of bees will be there. If you consider gray wolf optimization, you have a group of wolves will be there. So that means here the process here is, this is called random search optimization techniques, nature inspired algorithms or soft computing algorithms or random search methods. That means a group of people who are searching for a solution. Thereby we can get a better solution here. So all these meta heuristic algorithms or stochastic optimization algorithms, they are a population based algorithms. That means some sort of flock will be involved here. While writing the code also, we will consider, we have to initialize some parameters. In initialization, what we have to do is, we have to initialize the population number, group of birds, how many birds are there in the swarm. So that is the reason why these are all what we can call, and that means instead of one person finding a solution, a group of people are finding a solution. Let me tell you a simple example so that you should not get confused here. Let us say one room is there. In room, let us say we are playing some hide and seek game. A golden ring is present in one room. Let us say it is present here. And this is the opening of the room here. If you say one person to search for these a golden ring, then it will take, because the search space is this room, some area we are having. So it will take some more time to find the solution if you assign this task to a single person. Instead of that, suppose if you have assigned this task to 100 members, and if you give a condition that every person can share the information, that means whoever has entered into this room can share the information with others. So keeping that in view, if you allow these 100 members to, that means to find this golden ring which is present in this room, I think this process will provide you the better solution and fast solution when compared to this process. Why? Because these 100 members, they are searching for the ring and they can share the information among themselves. That means in this search process, you are using two methods. First method is you are depending on the potential of each person. And second one is you are allowing to transfer the intelligence of one person to another. Because of this nature, you are able to identify this particular ring in a faster way. Let me understand these two simple points. This is a very key point for any algorithms, whatever algorithm it may be. I have worked about 5 algorithms. In all these 5 algorithms, they work on the same principle. But among all the algorithms, the particle swarm optimization is a very simple algorithm and easy to implement, and it is giving a better solution, and it is a rugged algorithm. So let me tell you this process here with help of a simple example. Here in this case, in the second case, in the first case, you told only one person to search for this ring. So this person will search here, 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 here. At last, then he found a solution. That means it will take more time. Suppose, let us say the entry point is here. Let us assume if the entry point is here. If the entry point is here, I think he might have found the solution in a better way. That means if the initial guess is good, let us say 100 members are searching for this ring, let us say, let me relate this one to one algorithm called a Newton-Raphson method, I think, because you have already studied that one in your UG level and everything in power system analysis. In this Newton-Raphson algorithm, we have to give some initial guess. So if the initial guess is good, then you can find the solution in a faster way. Let us say it is just equivalent to have some sort of a door here near to this ring. If we have a door near to the ring, then that means the initial guess is good. Then in that case, it will find the solution in a better way. But if the entrance is here, then it will take more time for this single person to find the solution. So let me go to this second example. The second example, I have taken 100 persons are there in this room. Each person is having a potential to find the solution. That is important point. Each person is having a potential to find the solution. And each person is capable enough to share the information within the group. So that means they are exchanging the information to one another. In that case, what happens here? The process of searching will be very easy. Why? Because this person, 100 persons, they are having a potential and they are capable of transferring this information among themselves. Let us say one person is present here. He started his search and he came to this point. And he will tell here the solution is not there. So, okay, that means everybody in this group will understand the solution is not there. And another person has reached to this point. And he passes the information to others telling that the solution is present here. Immediately, all 99 people, they will rush towards this the point here, this gold ring here. So this example is so simple. In order to understand, I took this example. The same phenomena that we are mimicking on in these all the algorithms. That is the fundamental basis of understanding the algorithms here. Let me go a little bit further in our discussion. What is the goal of these optimization? The main goal here is, I told you, it is not minimization at the maximization. There are some variables will be there. Let us say some variables. Let us say I want to control the inverter. In inverter control, let me tell you the switching angles of the variables. Let us say alpha 1, alpha 2, alpha 3, alpha 4. Let us say, suppose if you are doing some sort of research work on MPPT controller, you are developing some algorithm to track the maximum power point. There you have to find the delta value there, delta. So that means depending upon your nature value, that means nature of the problem, then these decision variables will vary. So what is a point here? You are finding the variables here, decision variables, alpha 1, alpha 2, alpha 3, whatever it may be, decision variables, to maximize or minimize the function. What is the function here? Objective function. This is very, very important point in your research work. Whenever you are going for these, what is called nature-inspired algorithms or soft computing techniques, the first fundamental thing that you have to know is what is your objective function. That is the first fundamental point. So once you know this objective function, so your aim will be either minimization or maximization, your objective function, depending upon yours. Let us say I want to control the inverter with minimum percentage THD. So your objective is to produce the minimum, to minimize this objective function. In other case, you want to optimal location of fax devices. That is one case. Otherwise, you want to maximize the power flow in a transmission line. That is your objective function. So that means objective function is you have to design, you have to define the objective function, whether it is a minimization problem or maximization problem, whatever it may be. So these variables, what are the decision variables we're having? It is having some limits. That is what I'm telling here. So here we're having three terms here: decision variables, DV, a minimization, maximization, depending upon the objective function. So objective function here, and the constraints here, So let me tell you another example so that it will be very easy for you to understand here. Let us assume you are preparing a tea. If you are preparing a tea, your objective function is to prepare a good taste tea. The taste of tea should be high. Let us say that is your objective function, as simple as that. And what are the variables here? If you want to prepare a tea, you need a cup. Let us say a cup is having some ml, let us say 100 ml or 150 ml. And in the tea, you are using a tea powder, let us say 1 teaspoon of tea powder or 1.5 teaspoon of tea powder. And you are using some sugar here, let us say 1 teaspoon of sugar or 1.5 teaspoon of sugar, depending upon your taste. Suppose if you want more sweet in the tea, then you will use more sugar here. And you will use milk also. What is the milk here? 100 ml of milk you can use, or 150 ml of milk you can use. So let me correlate this simple example with this decision so that you will get some interest in understanding things. What are the decision variables here? Decision variables here is how much quantity of milk is required to produce a good taste tea. That is one decision variable. So here decision variables are milk. And another decision variable is sugar. And another decision variable is a tea powder. Is it clear for you, the terms? So the decision variables here are how much quantity of milk is required to produce the required taste, how much quantity of sugar is required to produce the required taste, how much quantity of tea is required to produce the required taste. That means all these constraints or all these decision variables are satisfying the, that means we have to keep in the objective function to validate our objective. That means our objective may be minimization or maximization. In our case, our objective is to produce high taste tea. Then another question is, we should not take milk as we like. We should not take sugar as we like. We should not take tea as we like. That means there is some limit here. We should not take 1 liter of tea, milk here. We should not take 1 kg of sugar here. We should not take 1 kg of tea here. There is some limits here. Suppose if you are a diabetic patient, then you should, your sugar limit is 0. Then if you use more sugar here, then it will be a 1.5 teaspoon. So that means every variable is having some limits. What is the limit of milk here? The limit of milk is 100 ml to 150 ml. What is the limit of sugar here? 0 teaspoon to 1.5 teaspoons. What is the limits of tea here? Let us say 1 teaspoon to 1.5 teaspoon. So that means these technical words, let me understand with help of live examples so that it will be easy for you to understand. So in objective function, if you want to formulate, what you should have here is, you should have decision variables. In your research problem, you have to identify what are the decision variables, which will provide you the required result here. Let me tell you in this case examples so that you will understand it. I want to control the multi-level inverter. Inverter I have to control at wide range of modulation index. And while controlling this modulation multi-level inverter, I have to see that it will produce less percentage of THD according to IEEE 519 1992 harmonic guidelines. That is our objective. We should not control our inverter as we like. There should be some IEC guidelines or IEEE guidelines. According to that, we have to control this inverter. Let us say if I want to control this inverter, I should produce less percentage THD, let us say less than 5%. Then I have to find out alpha 1, alpha 2, alpha 3, alpha 4 in such a way that it will produce less percentage THD. This is our objective function. Our objective function is producing less percentage THD. Here the objective function is to produce good taste of tea. Then here in this case, the variables are alpha 1, alpha 2, alpha 3, and alpha 4, alpha 5. Here the variables are milk, sugar, and tea. Then what is the constraint? The constraint here is milk constraint is 100 ml to 150 ml. Sugar constraint is so and so. Tea constraint is so and so. But here the constraints are 0 to 90 degrees here. Here the constraint of alpha 1 is 0 to 90 degrees. Constraint of alpha 2 is 0 to 90 degrees. Constraint of alpha 3 is 0 to 90 degrees. Alpha 4, 0 to 90 degrees. But alpha 1 should less than alpha 2, less than alpha 3, less than alpha 4. So this is how it can be formulated. So the main components of your research problem or whatever problem that you are going to solve should have objective function, should have some decision variables, that is called variables here, I told, and should have constraints here. So that is how it would be. 1 minute, let me erase this one. Right. Let me see here one example here. Let us say the maximization. You can, in problems such as, we can maximize the profit, you can maximize the efficiency, you can maximize the power flow in a transmission line. Similarly, in minimization, you can minimize the losses, you can minimize the cost of the transmission generation, you can minimize the noise. Suppose if in automobile industry suppose if you're manufacturing a car, your objective is your engine should produce less noise. Suppose if your engine is producing just noise like a tractor, nobody will buy that car. Suppose if you are using a controller inverter in medium voltage drive applications, variable speed drive applications, there the inverter is used. In that, the inverter should produce less percentage THD. Similarly, the size of the device. Let us say your smart mobile phone. Previously, I think your computers also. Previously, the size of the computer is so huge. Nowadays, we are using laptop, so the size is minimized. So like this, we have several things here. So constraints depending upon the problem, I told you. So optimization is useful in turning the knowledge into decisions. So that means there are several applications. Let us say, suppose, let me tell you applications here. All design problems, we are using this one. Let us say in electrical engineering problems, optimal power flow, where these algorithms will be used. Economical dispatch, load dispatch problems, widely these algorithms are used. Operating a plant with less CO2 emissions, this plant, in order to find a feasible solution, the algorithms will be used. The placement of optimal capacitor blanks and MPPT algorithm. Let me tell you with help of this MPPT algorithm, because nowadays everybody, they are doing research on these MPPT algorithms. Let me tell you why the algorithms are necessary to track this maximum power. You see here, let us say these are all the modules of solar panels. So because of some buildings or whatever it may be, there will be a possibility of some shaded portions which are present in the module during the daytime. So if you don't have a bypass diode, this particular module will act as a load. So in order to bypass this particular module during the shaded conditions, we are using a bypass diodes here. Suppose if you use a bypass diodes here, the PV nature, the PV curve of this particular setup will be like this. Let us say there are 4 modules are there. Let us say a 4S configuration. Let us assume 4 modules, 4 seriously connected the modules are there. One module is having this radiation of 100 watts per meter square and 900, 600 and 300 because of the partial shaded conditions. And if you implement this one in MATLAB, you will get this figure here. This is a PV curve here. You see here, if you don't have a bypass diode, it will be like this. If every one is 1000 watt per meter square, the PV curve will be like this. This is PV, this is P, and this is V. This curve will be like this. This is a peak point. That means with help of your naked eyes, you can identify this is a peak point. But you please a little bit careful in observing this figure here. Then where is a peak point here? This is a peak point, right? This is a peak point. And here also you have multiple peak points are there. These peak points are local peak points, and this peak point is called global peak point. Please understand these terms here. If you use this type of bypass diodes here for these for the shaded module to bypass the shaded module, and if you observe this PV curve, the PV curve will be like this. Then what is the objective of your MPPT controller? Your MPPT controller has to track the maximum power from this PV curve. If that is the case, then what is a peak point? The peak point is lies here. Suppose if you develop an algorithm which is not rugged in nature, there is a possibility of striking that algorithm at the local minimum itself, the local maximum itself. This is called local maximum, and this is called global maximum. These algorithms, if the algorithm is inferior, there is a possibility of the algorithm, it may stuck at the local maximum itself. Your algorithm should have capability to explore the entire such space and to find the global maximum, but it won't do. Because if you go for the deterministic methods like NR methods or some algorithms, let us say even P and O algorithm, let us say P and O algorithm. So it is unable to identify the global peak correctly. So in this case, again, you have to go for the nature inspired algorithms to find the solution. So this is a place where several people, they are using these nature inspired algorithms to find the solution. Similarly, if you want to tune some parameters in control systems, KP and KF and parameters, you can use these algorithms. Like that, we can use several places, particularly nowadays in machine learning also we are using these algorithms. Suppose if it is required to tune certain parameters to fit the data in a desired structure, some optimization we have to do there in machine learning algorithms. We will forecast the things with help of machine learning algorithms. After that, if you want to optimize the data, then again you have to use these algorithms only. It won't give you some feasible solution, machine learning algorithms. Again, you have to rely on the algorithms only. So that is the reason why it is better to concentrate on any good algorithm to find some sort of a solution for your research problem here. Just now I told in mechanical engineering also we are using these algorithms here, and noise reduction in engine. Here I would like to tell you one example. So I think recently, I think Tata Group company, they have launched one car and they observed that it was producing a lot of noise when they close the doors. So that means that noise can be reduced by formulating some objective function and design parameters, thereby optimizing that the noise can be reduced. So that means immediately it has been taken to the R&D team, and the thing that they have to do here is they have to formulate a problem, identify the parameters, formulate the objective function. They have to identify the parameters on which noise depends upon, thereby reducing the noise here. So that is how these optimization, that means algorithms, are helpful for us. So let me tell you in summary, the components are objective function is one component, variables are another component, constraints are another component. So whenever you are solving your problem, particularly in your research case, maybe it may be anything. So what you have to do is, the important one you have to do is objective function you have to formulate. That is the first step. How the objective function will be formulated? You have to identify the variables on which, suppose if it's a minimization or maximization, on which it depends upon. That you have to identify it. So the variables you have to identify it. Then you can formulate the objective function. So these variables having some limits, that is called constraints. So these are the important steps that we have to find here. So this example I have already told you. Let me go to the problem once again, to the algorithm. These are all things which I have already explained here, right? So what are the steps that are involved in implementation? This is important. What are the steps in implementation? Let me tell you very clearly. The first step is a development of objective function with variables and constraints. This is the first step that everybody has to do. And what is the second step? Second step is selection of algorithm to solve a problem. Here, everybody is having some notion that this algorithm is good and that algorithm is bad. That is not like that. For a particular problem, what you have to do is you have to identify a few algorithms and you have to apply on it. One algorithm will provide you a better solution. So that means it doesn't mean this algorithm is inferior. Remaining algorithms are inferior. So for that problem, this algorithm is providing a best solution, and remaining algorithms, they are not providing a better solutions. So those algorithms may give some better solutions in some other case. So you should not jump into a conclusion this algorithm is good and this algorithm is bad. There is no universal best algorithm here. So that is explained by no free lunch theorem. This is called NFL. So according to this NFL, what happens now? They have taken one problem and they have applied several algorithms. And then they came to a conclusion that no algorithm is good and no algorithm is bad. That is a conclusion they got. So that is called no free lunch theorem. So anyhow, what are the characteristics of algorithm? That is important, right? The characteristics of algorithm is it should be robustness of the algorithm should be there. That means good performance for a wide class of problems, and it should take less computational time. I would like to remind one word here. before these algorithms, suppose if you want to solve non-linear problems with help of deterministic algorithms, it will take long computational time. Because of long computational time, now they are going for these algorithms. So one of the good quality of your algorithm is it should take less computational time. And another one is accuracy in providing the results. It's the ruggedness of the algorithms. You should have a ruggedness of the algorithm. So these are the three characteristics that the algorithm should have. Suppose if you have taken some algorithms and if you have applied on your objective function and if you find a solution, then you have to compare the algorithms in this way: robustness, the computational time, and accuracy. And ultimately, the last one is validation. Validation means the practical implementation. So all these three steps I have implemented in one particular application. That application is control of multi-level inverters using the particle sum optimization technique. So all these steps I have implemented and then validated the results. So let me go to the classifications of objective function fastly, and then we will go to algorithm. Objective function, I told objective function means maybe a single variable or multivariable. Suppose if you use alpha 1, alpha 2, alpha 3, alpha 4 is a multivariable. Suppose I told in MPPT algorithm only delta we are calculating. It is called a single variable optimization problem. Multivariable means just now I told alpha 1, alpha 2. Constraint means it is having some limits. Let us say a milk is there 100 ml to 150 ml. It's called constraint. Non-constraint means there is no limits. So like that, maybe a single objective will be there and multi-objective will be there. So that is a broad classification of objective function. So once this stuff is ready, then we are going for these algorithms here. Let me tell you very clearly the limitation of existing algorithms. Let me say I want to find some minimization or maximization. Let us say this one is there. Let us say a sine wave is there. I want to find the minimum value and maximum value. Minimum value is equal to the -1 and the maximum value is equal to 1. So if you want to find this one, what we have to do here is we usually go for calculus based approach. The calculus based approach means when the gradient vanishes, it will reach some point, stationary point. That is main point you can understand here. That means if you see here this point, there is no gradient here. So the place where the gradient vanishes, that stationary point may be a minimum point or maximum point. If the gradient vanishes here, let us say the initial guess is here, the gradient has vanished here. So this is a minimum point here. Let us say this one is a maximum point here. That is how these gradient algorithms will work. Let us say the function is not clear like this. The function is like this. Just now I told the PV curve of MPPT controller, which you are using MPPT control under partial shaded conditions. Then how it is, this is a P and this is V. It will be like this, right? It will be like this. So you have a multiple global peaks. Here you are having a, what is called, this is called global minimum and this is called local minimum. Here it is local peak and global peak. So that means if you are going towards the maximization, these are the terms you will get here. And if you are going to the minimization function, you are getting terms here, global minimum and local minimum. So the problem here is if you have a multiple minimums like this, you see here, the function is not linear, non-linear in nature. In this case, what happens here is it is difficult to find the solution with help of existing algorithms. That is the reason why we are going for these optimization algorithms, these stochastic algorithms or nature-inspired algorithms. In this case, suppose if you are using MPPT controller to track the maximum power here. So if you use this NR method, some methods, a P and O method, it will track at the local minimum only. It won't go to the global peak. So in order to have ruggedness or otherwise flexibility to track the maximum power point, you need some rugged algorithms. So that means you have to work on some various algorithm which is capable enough to track this maximum power point here. So let me see here how this algorithm is working. This is what I have already explained here. Let me go straight away here, the PSO algorithm. Let me tell you in a simple way, the reason why we are going for this PSO algorithm is, I have worked on 5 algorithms. Among all 5 algorithms, this algorithm is very simple algorithm. That is the first thing. But for my objective function, what is my objective function? My objective function is I have taken one multi-level inverter that is called a 3-phase cascade H-bridge 11-level inverter. Okay. Now I am planning to implement this. That means the same topology in control of some electric vehicle also. That research is going on. We are doing that with help of some PhD student. We are doing that work here. So here, what I have taken here is I have taken this inverter. This inverter is controlled at the wide range of modulation index to produce a minimum percentage THD. Why modulation, wide range of modulation index we have to control? Because for variable speed drive applications, we have to control the inverter at the wide range of modulation index. That is the point. So for the same thing, I have applied a few algorithms. Let me tell you here, NR method I have applied, genetic algorithm I have applied, and PSO algorithm we have applied, and TLBO algorithm I have applied, and Jaya optimization algorithm we have applied. So if you apply the same objective, the objective function is same for all the cases. And we have tested the ruggedness of all algorithms in the control of this inverter. Among all those inverters, the efficient, rugged, and algorithm is particle sum optimization technique. It has solved, that means the problem, what are the problem that we have, is with a less computational time, and it is very accurate, and ruggedness is also there. That means a consistency is there. Each time when you run the problem, the accurate results which you are getting is apt. So that is the reason why I want to emphasize a PSO algorithm. We can try, but in your case, for your research problem, maybe J optimization may provide better solution. For your problem, may TLBO algorithm may provide a better solution. But here in this, for my case, the PSO algorithm has provided a better solution. So the reason, that is the reason why I am concentrating on the PSO algorithm. So PSO algorithm, I'll tell you in 5 to 10 minutes in a very simple way. This is very simple algorithm. Why I like this algorithm? Because this is developed by one electrical engineering professor. So that is another reason why I am having some short corner on this algorithm. Anyhow, these are the two persons who has proposed this algorithm. That is Kennedy and Eberhard. These are the pictures of these two persons here. So the point here is they have developed the algorithm which is inspired the social behavior of the birds flocking or fish schooling. So I told, so in the beginning slides, I told several points how in a design applications they have mimicked the nature. Here the mimicking process is the way how the birds will find the food. The way how the birds will find the food. So that behavior, the social behavior, they have mimicked in solving some engineering problems here. In my case, the problem here is to control the inverter with minimum percentage THD. So how these algorithms will work? This algorithm will work very simply. I'll tell you, let me take one example here. 1 minute. Right. Let me take you this example so that you can understand the algorithm very simply. This is your objective function. Let me, in your case, if you say MPPT controller, this is your objective function here. You have global peaks if there, and this is a local peak, and this one is a global peak. In my case, this is a global minimum, and this one is a local minimum. Let us assume like that. So my point here is I want to reach this minimum point. Let us say this is a minimum percentage THD in my case. Okay. So at minimum point, the fish is present here. So my point here is there are two fishermen are there. They are trying to catch the fish. You see how they are catching the fish. And if you mimic the same process in terms of an equation, then that means you can understand this PSO algorithm. So let me see what happens here. Let us say the first person is there. He started his fishing at this point. Let us say the person A is there and the person B. So he started fishing here, and this is the position, first position of a first person. This is the first position of a second person. Let us assume like this. So they have a capability of transferring the knowledge to another. So you see here, this first person, he started fishing and he observed nothing is there here. And immediately he transfers the same information to others. So this is called communication. So that means this person is having potential to find the solution. That is the first one. Second one is the person is having a potential to transform his intelligence to others. So that means this person is having intelligence of its own, and the person is having information. He can receive the information from others too. Right. So then he passes the information and telling that nothing is there here. And another person, the person B, he also started his fishing and he observed nothing is there here. And he communicated the same thing to others. That means these two persons which are present in the group or swarm, they are communicating with each other. Let us assume your imagination, let us say a group of birds are there, several birds are there here in this space. Let us say this is a such space. In this such space, there are several birds are there here. These several birds, what they are doing is they are trying to catch the food, and they are also sharing the information among themselves. That is what they are doing. Got it? So that means, so first person has shared the information to second person has shared the information to first person, right? Then you see here, first person has reached to this position. Let us say this is the second position of a first person, and second person has reached to the second position. So this is the second position of a second person. You see here the second position, second person almost reached the fish here. That means immediately he transferred the same information to others, telling that here the fish is there. Don't waste your time in the process of searching for food. Straight away you come here. Then you see here, immediately that person has reached to this point. The same animation which I have told, they have mimicked in terms of an equation to find the solution. So in the place of A person and B person, we're having a boards like this. Birds, they are searching in the such space for food. Such space will be there, such space for food. And each person is transferring the information among others. That means among others. Then what happens here? When one bird finds a food, immediately that bird will pass the information to other birds, and all other birds will follow. This is how the such process is. So thereby what happens, because of self-intelligence and getting some sort of intelligence from others in the process of searching for the solution, the computational time is less, and there is a possibility of getting good results, and some complex engineering problems also can be solved by, that means by mimicking this phenomena. So what we are doing actually in the case of PSO algorithm, that we will see now. We will see the mathematical model here. The mathematical model is very simple here. Let me tell you here. Let us say this is the position of a particle. Let us say ith particle here. Ith particle is present here. Just understand here. It's very simple here. It is just like a phasor diagram only. This is a position particle. Let us say present position of a ith particle. Present position of a ith particle. So in the group, let us say this is a group is there. Such space is like this. This is a group here. Okay. Each particle is having its best position. Is it right? Each particle is having its best position. Let us say the best position of the ith particle is like this. Let us say this is pi of t. This is the best position. Got it? This is the first. This is a particle position is present now. It is having some memory. That is what I am telling. It is having its memory. In the memory, it is having a best position is there. Okay. But in this group, there will be one bird which is trying to find the food in a better way when compared to others. So that position of that bird is the global best. That is called G of t. This belongs to entire swarm. So in entire bird, one bird has the best position. Let us say, I'll tell you, suppose if we have a group of 30 students in the class, there will be one student who is getting some good percentage, like that, among in the class. In the same way, in the swarm, entire swarm, one bird is having a best potential, that is called best position, that is called G of T. It is not the ith particle. It belongs to entire swarm. That is why I have not written here Gi of T. Got it? So then this bird, let us say the position of the bird is traveling with this velocity. Let us assume. Let us say this is V of T, Vi of T. It is traveling in this direction. Vi of T. It is traveling in this direction. So what we can understand here is this particle is having some memory. And this particle also knows there is a best position in the entire swarm. So this is the bird. So here the food is there. So we have to go towards this direction. So that intelligence this bird is having. Then how it is updating, that you have to know. How it has to updating. It has to update. Its position and velocity has to update. Let me tell you some simple examples so that you can understand in an easy way. Let us say I want to buy some car. I want to buy some four-wheeler. If you are already using four-wheeler, you have some memory. So I need these specifications. In my car, these are the facilities I require. So that means that information already you are having. This is called some information. And you will inquire with others. You will inquire with others. And they will tell some information. So considering this information and that information, you will update yourself. Updating means what happens? You will go and buy the car. So here updation is nothing but here the position and velocity will update because the bird has to move, no? Because the food is present here. This is the best bird in the swarm. All these birds have to move towards this direction. That means its position and velocity has to be modified. How it will be modified? It will be modified in this way. You see here, this is a vector connecting these 2 points. This is a vector here. This is a vector. I think this one is x1 and x2. I think you know the equation of the line, pi of t minus xi of t. And this one is, you know the equation of the line. So this point minus this point, x2 minus x1, the g of t minus xi of t. This is another point. Okay. And the point here is this particular position has to be updated. How it will be updated? How it will be updated means it tries to move in the same velocity. This is the first point. In the same direction, it tries to move. This bird will try to move in the same direction. And it will observe that it is having some best position. That means it will move towards a parallel to the best position, towards the best position. And it will observe that there is a best position in entire swarm and it will move towards the best position. So that means it is taking 3 steps here. First, it will try to go in the own way. Then it may observe that it is not the correct one and it will move towards its own best position. Okay. Then it will start updating itself, moving towards the global best position here. So that means the moment when it reaches to this point, this is the new position of a bird. That means even the bird is trying to move towards this bigger this bird, main bird. So first it has to randomly, it cannot straight away, it cannot come from this point to this point. So it will move to this point and it will move to this point and it will move to this point. Like that it will come step by step. So in first step, it has reached to another position. It's called xi of t plus 1. In next iteration, it will come here. In next iteration, it will come here. That is how it will be updated. So if you write this particular thing in terms of equation, it is an addition of 3 vectors here. This is first vector, this is the second vector, and this is the third vector. The resultant of these 3 vectors will give you the velocity updation here. It is simple. If you understand the phasor, then it is very easy for you. No other algorithm is having this much of simple in equation here. Only this algorithm is having this much of simplicity in understanding the equation here. Let me try to understand this equation here. The first vector is vi of t. So vi of t, this is vi of t. You forget about w, I will tell later. And this vector is parallel to this vector I told you, no? So what is this vector here? P of t minus x of t. So p of t minus x of t. It is clear. Next, third vector is parallel to this vector. So this vector is parallel to this vector I told you, no? So what is this vector here? P of t minus x of t. So P of t minus x of t. It is clear. Next, fourth vector is parallel to this vector. So P of t minus x of t. It is clear. Next, This vector is nothing but the line joining of best position and this position, right? So what is this one here? G of t minus this one. So this is G of t minus this one, right? So the summation of these three components, first component, second component, the third component, it will provide you the velocity, updated velocity, that is Vi of t plus 1. So what is the velocity at which it has to update to reach this position? Because once you know the final point, what you will do, we will increase the speed, right? That is, velocity is increased here. So the birds will increase its velocity and it will move. So once the velocity is increased, then its position will change. So what is the new position? Xi of t plus 1 is a new position. That is nothing but old position plus velocity. So here what we have to do is, here we are having some parameters here. The first one is C1 and second one is C2. This is very, very important point here. What is C1 and what is C2? C1 is nothing but cognitive parameter. Cognitive parameter means your intelligence. Suppose if you want to buy a car, you have your own information. So that is called C1. Suppose what is C2? C2 is nothing but it is updating towards the best position in the swarm. So C2 is nothing but the social information. This is called cognitive parameter, and another one is called the social parameter. Cognitive parameter and social parameter here. Then what is the beauty of this algorithm? Any algorithm, suppose if you are using for your problem, it should have 2 points. First one is exploration and exploitation. What is meant by exploration and exploitation? Let us say your search space is like this. This is a search space. Let me tell you, I told in my case, I am finding out of alpha 1, alpha 2, alpha 3, alpha 4, right? Let us say if it is MPPT algorithm, the value of duty cycle is equal to 0 to 0.9 because you are using a boost converter here. So then between this alpha 1 is having limits of 0 to 90 degrees. I told that one. Between 0 degrees to 90 degrees, this is the search space. This is the search space. That means there is one value which is feasible for you, which will satisfy your objective function. So this is a search space here. So in this search space, you see here between 0 degrees to 90 degrees here, how many values you are having here? You are having infinity values because 0 is a solution, 0.1 is a solution, 0.2 is a solution, 0.3 is a solution, 0.4 is a solution, 0.5 is a solution. Like that, you have so many solutions are there. Infinity solutions are there. So that means your search space is so high. If the search space is so high, what is the probability of finding that one? Your algorithm has to give that solution. So that means your algorithm should be capable enough to explore around the search space. That is one important point. That means entire search space, it has to explore for the solution. You got it? Next one is exploitation. Exploitation means suppose if inferior solutions are there, it has to kill that inferior solutions. Why? Because in further iterations, it will be problem for you. So what it is doing here is, but killing also, you should not kill abruptly. Why? Because let us say, let me tell you another example to understand this exploitation. Let us say one student is there. One student may not perform well in test 1, but he can perform well in test 2. Suppose if you delete him, disconnect him after observing test 1 results, it's not good. That means you are not giving a chance to a person to update himself. So that means your algorithm should be capable enough to provide enough enough time for the particles to update themselves. That means you have to give sufficient time for the particles, enough time for the particles to update themselves. If you kill them, that means well in advance, then there is a possibility of losing the balance. So that means the best algorithm, what you have to do here is, your algorithm should have balance between the exploration and exploitation. So exploration means it has to search around the search space for the better solutions. That is exploration. And exploitation means discarding the inferior solutions. Discarding the inferior solution. You should not discard too much, but there should be some balance between that. Just now we have seen this equation here. These are called C1 and C2 are called cognitive parameters, and everything I have explained. Let me see this diagram here. This is a flowchart of particle sum optimization algorithm here. So for any algorithm, what we have to do is first we have to initialize the parameters. What are the parameters we have to initialize? It's very simple here. You have to initialize this one C1. You have to initialize this one C2, and first you have to initialize, that means velocity. What is the initial velocity and what is the initial position? So all these things you have to initialize it. That is the first thing that you have to do. Another point I would like to tell here, these are all called algorithmic specific parameters. That means for any algorithms, you have to tune some parameters. Random numbers are there, C1 are there, C1, T2 is there, inertia weight is there. So that means all these things, that inertia weight also you have to what's called initialize here. So that means these are all the parameters you have to initialize for any algorithm. Suppose if you take a genetic algorithm, you have population is there, you have a mutation rate will be there. So those things that you have to initialize here. Like that, you have to initialize some parameters here. Those are called algorithmic specific parameters. After the initializing this one, those parameters, whatever the initial values, alpha 1, alpha 2, alpha 3 in our case, what we have to do, we have to substitute in the fitness function here. Fitness function is nothing but objective function. So that is objective function we have to substitute here. So once you calculate the fitness values, if it is okay, fine. So if it satisfies, it's fine. If not, then what we have to do, we have to update the particle velocity and location vector. And again, we will calculate the fitness values. So if you find optimal value, then we will terminate it. If not, again, the process will repeat. So what is the process here? First, we have to initialize it. And already you have developed an objective function, you will substitute in that. If the solution is fine, okay. Otherwise, what we have to do, you have to update the velocity and position. What is velocity and position here? This one is velocity. Just now I have told this with the help of some vectors. This is the velocity should be updated and position should be updated. Only two equations, very simple. That is why this algorithm is so simple. So that is how we will do. And then we will terminate it. So this terminating, we can keep some conditions. Let us say maximum iterations is 1000. Otherwise, the minimum value of error is 0.01. Like that, we can keep some conditions and then we can terminate it here. Right. Let me see one example quickly so that you'll get some knowledge how we can do this one. Let us say this is a function is there. X minus 7 is equal to x minus 7 whole square. We have to minimize it. I think you know the answer. I think there is a simple one. There is no need of calculator here. What is the value of x to minimize this function? So minimizing means the function should be, this f of x should be 0. So if you want to make this one 0, what is the value of x? X should be 7. I think everybody knows that one. So 7 minus 7 whole square, so that is equal to 0. So you see, with help of PSO algorithm, how we are achieving the conditions here. Let me see here. First one is we have to generate the population here randomly. So let me say I have taken 4 particles, otherwise 4 birds here. X1, X2, X3, X4. This is called population. Just recollect the flowchart here. Flowchart, what we have told, initialize the population. Let us say I have taken 4 birds here. 4 birds are having numbers 2.234, 9.547, 4. We can take randomly. That is why we are calling this one is random optimization, the random algorithms here. Random. These are called meta heuristic algorithms here. So randomly I have taken. I don't know what is the solution, but randomly I have taken from 0 to 10. Because he has given x value should be less than 10, 0 to 10. It is present between 0 to 10. So randomly I can assume any values which you like. You can assume 6.7 or 8, whatever it may be. You can assume any values which you like. So in this case, randomly I have assumed the values of 2.234, 9.57, and I think with this you can understand here this 5.7 is somewhat nearer to this what is called your objective function here. So what is the first thing we have to do here? First thing we have to do here is we have to substitute the objective function. What is the objective function here? Objective function is x minus 7 whole square here. So substitute x minus 7 whole square and then find the equation here, x minus 7 whole square. What is the value of x here? X is equal to what is the first value? 2.234. So substitute x is equal to 2.234 and substitute the value, you will find this value. Similarly, second value, similarly, third value, similarly, fourth value, like that. You see here, what is your aim? Your aim is to minimize the function. Minimize the function. What is the minimum value of the function? Ideal value is 0. When x is equal to 7, then what happens? 7 minus 7 whole square is equal to 0. So your objective function should be minimization. So minimization means function. You just observe where the function is minimized. So function is producing a minimum value when x is equal to this value, x is equal to 4. So x4 function, you see x4, what is x4 here? x4 is equal to 5.625. That means actual value is 7, but initially if you substitute here, among all these values, you have identified that this is the best value among these 4 persons. Got it? So that is why this is called global best. Among all these group, which one is the best here? This one is the best here, because x1 is somewhat a minimum value function. If you substitute in the function value, so it is producing the minimum values. That is why it is called global best. So that means what we have identified the G best here in this algorithm. I think if you remember the equation, this is the G best in this form. Then what is the next thing we have to do? Next thing we have to do is we have to update the position and velocity. Velocity and position we have to update. So how we can update the position and velocity? Let us go to the equation once again here. Let us assume C1 value is equal to 2 and C2 value is equal to 2. Random numbers you can assume. It's okay, fine. And you see here, this is the equation is there. Initial position, initial velocity is equal to 0 for every case. Then you see here for first case, let us assume I am calculating velocity. Velocity is equal to initial velocity, this is 0, plus C1. C1 is equal to 2, random number, any random number from 0 to 1. So let us consider here random number is equal to 7452. Next, P best, best position of the particle itself. What is the first position? 2.234. What is the position, best position for that particle? Its own value, 234 plus C2. C2 is equal to, what is the value of C2? 2. What is the random 2? Random 2 is equal to 0.3287 multiplied by G best. Just now we have identified, no? One best value is there. What is that best value? 5.645. So 5.645. Okay. So then you have to substitute the x1 value. What is the value of x1 value here? Minus, what is the x1 value? 2.234. Is it clear for you? So that means you are updating the velocity now. So once you calculate everything in this equation, I think you are getting 2.242314. Some value you got here. This is the velocity. But what you have to find out here? You have to find out the position. So that means once the velocity is updated, the position has to be updated. That is x of t plus 1 is equal to x of t plus v of t plus 1. This is what is there now. So that means what is the new position here? X of t, original position. What is the original position here? 2.234 plus what is the velocity here? 2.2423. That means if you add these two, now the new position for the x1 is 4.4763. Just observe here, your initial position is 2.24. So I don't want to extend this one. Let me tell you fastly. 2.24, let us say. And actually your ideal position is 7. Let us assume that is 7. So that means you have to increase your position. You have to increase your position here. So your position has been increased in the first iteration by 4.4763. Got it now? That means this is how it is updating. How it is updated, it is not 1.24, right? It is not 1.24. It is 4.47. That means it is because the value is 7, this value has to be increased. So that means your algorithm is in the right position. It is updating the values. Like that, you can do iteration for all the values. And finally, after some iterations, let us assume, you will find the best solution. Let us say the best solution here is, in this case, after doing some iteration, something like that, we have found the best solution is equal to, here the value is equal to, this is the important conclusion that we have to consider here. The value is equal to, let us say 6.36, something like that. That is the best position here. 6.36 like that. That is the best position. So the one point you have to understand here is regarding these algorithms. This is the limitation of these algorithms. I will tell you here. Limitation of these algorithms. What is the limitation of the algorithms here is, here you got 6.5 like that, the best solution. Let us assume 6.5. What is the actual value of x in your case? X is equal to 7. But with help of this algorithm, you got only 6.5. It is not 7 value, exactly not 7. But if you go for some calculus based approach here, x minus 7 whole square, and if you do everything, you will get the value. But here, in this case, these algorithms, they're having a limitation. They will go only near global optimal solution. That is the main limitation of these algorithms here. But whereas the remaining algorithms, they will go deterministic algorithms, they will reach the global position. But these algorithms, they won't go exactly global minimum, but near global minimums. Let us say it will be 6.9999, something like that, or otherwise 7.11111 like that. So it won't give you exact values of 7. That we will verify with help of test case also. Let me go clearly here. Let me see the test case here. The test case here is, I want to control inverter. I told this is the inverter. So first step is I want to develop the objective function. Okay. The objective function in my case here is, let me tell you clearly. So this is the inverter. This is a three-phase cascade H pitch 11 level inverter. So that means 11 level means how many sources we are having? 1, 2, 3, 4, 5 sources we are having. 2 S plus 1. So if you substitute F is equal to 5 here, you will get number of levels is equal, output voltage is equal to 11 levels you will get here. So this is the configuration which is usually used in medium voltage drive applications. So I want to control this inverter at wide range of modulation index. That is my point here. So in this case, what I have to do here is, I have selected one modulation technique. That modulation technique is selective harmonic elimination technique. Actually, any inverter can be controlled by using. Sir, can I take 10 minutes extra, sir?
Sure, sir.
Just 10 minutes, ma'am. I will conclude in 10 minutes.
Okay, sir.
Yeah. Suppose if you want to control any inverter, it will take, there are two ways we are having to control the inverter. One is fundamental switching frequency control and another one is high switching frequency control. So fundamental switching frequency control means it is low switching frequency control. In that one, the one method is selective harmonic elimination method. So I have taken this method of to control the chosen inverter. So if I take that method, I have formulated the objective function. The objective function is like this. So this is the first step I told. So how I got this objective function, that also I will tell you. So this is the number of levels is equal to 11. I told 11 level inverter. Let us say this is 5 VDC, 4 VDC, 3 VDC, 2 VDC, VDC 0, minus 1 VDC, minus 2 VDC, minus 3 VDC, minus 4 VDC, minus 5 VDC. If you count that one, it will get 11 levels. Any periodically repeating waveform, if you want to express in terms of an equation, we have to apply Fourier series. I think Fourier series is equal to a naught by 2 plus summation n is equal to 1 to infinity an cos n omega t plus bn sin omega t. And if you calculate every other parameter and if you equate to all other harmonics to 0, this is the Fourier series expansion for this waveform which I have told. And if you relate all other harmonics to 0, that means I want to eliminate 5th order harmonic to 0, 7th order harmonic to 0, 11th order harmonic to 0, 13th order harmonic to 0. If I equate like this, I will get this some function here. This function is called objective function. This cannot be minimized with help of some deterministic modulation techniques, because this is called non-linear transcendental trigonometric equation. It is having a multiple local minimums. Just now I told it is having multiple local minimums like this. So somewhere down the line, the global minimum is present. That minimum is nothing but the finding out of the values of alpha 1, alpha 2, alpha 3, alpha 4, and alpha 5 to find the percentage THD. That's it. So my first step is objective function. I have formulated the objective function. That is clear. So the next one is, it is having some constraints. I told you my objective function variables are alpha 1, alpha 2, alpha 3, alpha 4, alpha 5. It is having some constraints. The constraint is alpha 1 less than alpha 2 less than alpha 4 less than alpha 5 less than, all firing angles should be less than pi by 2. I told such space. Such space is 0 degrees to 90 degrees. No, this is a such space. So that is the constraints of these objective variables here. So what I have to do here is I have developed a code in PSO algorithm to find the solution. So the solution means alpha 1, alpha 2, alpha 3, alpha 4, alpha 4 I have found. If you see here, let us say I will go directly to this method here. Let us say at a modulation index 0.2, I developed the algorithm and run that code, then you will find the solutions. You can find the same way for the duty cycle also, whatever it may be. For your own research problem, you can do that one. And optimal load shedding of generators, you will find the solutions as generators. So then alpha 2, alpha 3, alpha 4, alpha 5. So I run the code for a different modulation index from 0.2 to 0.1. At each modulation index, what is alpha 1, alpha 2, alpha 3, alpha 4, alpha 5, I have calculated. And each modulation index, what is a percentage THD also we have calculated. So usually in the drive applications, a higher modulation index will be considered here, above 0.5. And it is having some sort of IEEE 590 1992 harmonic guidance. So it is observed that your algorithm has successfully controlled the inverter at higher modulation indexes with less percentage THD. So in order to validate this one, we have done some experimental results also. So why we have went for this PSO algorithm? Because your Newton-Raphson method, deterministic method, does not find the solution at different modulation index. You can see here. So because of that limitation, then we went for these nature-inspired algorithms. Suppose if you are doing a research, don't simply jump into conclusion because this is a fancy in nature algorithms. We have to do some sort of research in this area. Not like that. You observe the limitation of existing algorithms. And to address this limitation, then you have to go for the algorithms here. You see here, Newton-Raphson method, lower modulation index, it could not find the solution. And at above 8 also, it could not find the solution. And below that also, some modulation index, it could not find the solution. Because of that reason, we went for the particle sum optimization method. So what we have to do here is, in real-time implementation, what we have to do here is, we have to run a code, and then we have to write some VHDL code for these switching angles, and we will give to FPGA controller. And this from the FPGA controller, we are producing the firing pulses. Those firing pulses will be given to the driver circuits, and then we will give to the switching devices. And then we will observe this output voltage with help of a power analyzer. Let us say this is Ecogawa power analyzer at different modulation index. So then if you take some sort of hardware results also, these are all the simulation results, and this is the hardware results. This is a line-to-line output voltage waveform. And this is the output voltage waveform, which represents the percentage THD. The percentage THD which is present here is practically, it is very less. It is, I think it is 5 point something like that. So it complies with the IEEE 519 and 1992 harmonic guidelines also. So that means, let me summarize what I have told here. The main limitation of, before summarizing, let me tell you some limitations here. The main limitation is there is no guarantee of finding optimal solution during some cases in time. That is one point. And another one is there are some of so many parameters will be there. Algorithmic specific parameters I told, no? And I told to assume the value C1 is equal to 2, C2 is equal to 2, and inertia weight will be there. So those parameters we have to trial and error method, we have to choose the values. That is another point. And computationally, you need some high computational computers to solve this one. Computationally, it is expensive. And main important point here is they will reach the near global minimum. Let me tell you the waveform, and then I will explain you. Suppose if you see FFT analysis in the case of Newton-Raphson method, this is in the case of Newton-Raphson method. Can you see how the order of the harmonics? Order of the harmonics are almost zero only. There, that means minimum harmonics are present here. Harmonics are eliminated to a greater extent here. But if you see PSO algorithm, even though the total harmonic distortion is 9.10, you don't have a clear harmonic profile here. So that is the main limitation of these algorithms here. So let me summarize the outcomes here. The outcome is, I would like to find out, tell you, first one is what is the importance of these nature-inspired algorithms, and what are the components that are required to formulate the things here, and what is PSO, and how it can be implemented with help of some numerical example. And also I have taken one practical example, and then how this PSO algorithm will find some sort of results that I have tried to explain you. So these are all the points from my side. You are free to ask any question, so that my knowledge may be helpful for you to find some solutions. So if you have any queries on this, you are free to ask.
Participants, if you are having any queries, please post in chat box. Or you can speak directly to the resource person.
Sir, namaste, sir. Good morning, sir.
Sir, good morning. Good morning.
Sir, this is Venkateswaru, sir.
Sir, tell me, sir.
I am research scholar.
Sir.
Sir, I am doing the research in multi-level inverters, sir, in fault-tolerant multi-level inverters, sir.
Very good, sir.
Sir, I have observed in the MATLAB swimming pool, I have observed that I have given the 200 volts of input volts, sir.
Okay.
But the output to voltage, I have observed the THD analysis, account THD analysis. The fundamental value is more than of 220 volts, sir. It is possible, sir?
Usually in control of multi-level inverters, our objective is to produce 100% of fundamental magnitude of fundamental voltage.
Yes, sir.
But in practical observations, I too observed there will be sometimes 105% and 110% also.
Okay.
In some cases, I observed that. In my simulation also, I observed that case. There is no specific reason for that, but as far as my knowledge is concerned. But the point here is, anyhow, our objective is to produce 100% of fundamental magnitude of output voltage. That is suffice for our purpose.
Yes, sir. Because of increasing.
I know that one. I observed in my case also. I observed that.
Okay.
I got fundamental output voltage somewhat greater. I have received in my case also.
Okay.
But I didn't go deep into that because I quite satisfied because I got 100% of fundamental output voltage. Like that I thought.
Okay.
So that is right only. I too observe the same thing.
Okay, sir.
So you be in touch with me in I have shared my email ID also. Let me see. Let me go through that.
Okay, sir. Okay.
So what problem you are solving, sir? In your case?
Sir, fault tolerant analysis, sir. So during the fault conditions of any switches, even the fault condition, I getting the 5-level output voltage.
You can use machine learning algorithm to forecast that one.
Okay, sir. So for controlling of this multi-level converters, I have chosen the SPWM techniques, sir.
Yeah, the sinusoidal pulse width modulation you are taking.
Yes, sir.
Okay. That is a high switching frequency modulation technique.
Yes, sir. High switching.
Yeah. Okay, fine. You can use some that is machine learning algorithms to forecast that faults and everything.
Okay, sir.
And then you can optimize it, and then you can control it. So that would be the flow nowadays, the trend of research nowadays. Okay.
Thanks.
Right.
Hello.
Hello, sir. This is Jyoti from MVIT Bangalore.
Tell me, ma'am.
Sir, I have a small doubt.
Tell me, ma'am.
Yeah, for your problem, you are considering the cascaded 11-level inverter, right? And your objective function is to minimize the percentage THD.
Yes, ma'am.
And you define the function where F is equal to alpha 1, alpha 2, something you are taken, right?
Yes, ma'am.
So in that, what is the initial guess values you are taking for alpha 1, alpha 2, alpha 3, and alpha 4?
Yeah, you have asked the right question, ma'am. Suppose in order to implement these algorithms, let us say Newton-Raphson algorithm, suppose if you write MATLAB code in Newton-Raphson algorithm. We have a MATLAB that is called code to generate random values for initial guess. Like this, suppose initially we have to choose the values of alpha 1, alpha 2, alpha 3. We will use the command called random. So randomly it will take any value between 0 to 90. So there is no thumb rule that we have to take this value. So randomly it can take any value between 0 to 90 degrees. Just now I have taken one example of solving some numerical example x minus 7 whole square. The values of x lies between 0 to 10. Randomly I have taken any value between 0 to 10. Like that, your MATLAB code will take any random value between 0 to 90. Suppose if the same thing has happened in the Newton-Raphson algorithm, if your guess is good, you will find the solution in a very quicker way. But if the guess is bad, it will take more time to find the solution. But the beauty of this PSO algorithm is, even though if a guess is bad or good, whatever it may be, it will converge to a global minimum or global peak in a better way when compared with the deterministic algorithms. So there is no thumb rule that we have to take these random values only. Any random value between 0 to 90, but the condition is alpha 1 should be less than alpha 2, should be less than alpha 3, less than alpha 4, less than alpha 5. That condition has to be satisfied.
And how you are considering the C1 and C2 for your inverter, sir? That is,
so that is what I told, ma'am. These are all called algorithmic specific parameters. So these are the limitations of these, all these nature inspired algorithms is, we have to take some values like this. What is called inertia weight, we have to take C1, C2, we have to take. So as long as your guess is correct here, your solution will be correct. This is how trial and error method only we have to take it. So there is no thumb rule that C1 is equal to 2, C2 is equal to 2, like that. So these are all depending upon your literature and your depending upon how you run the program, you have to come to a conclusion. What should be the number of population, bird size? So that is how these are all the limitations of these algorithms.
So
but
for
in not
value, sir, you're considering?
In my case, I have considered 1.5, ma'am. But for this problem, I have taken 2.
Okay.
But in my case, I have considered different values. 1.5 I have considered. For in order to converge in a faster way, I have considered here 2 and 2 for this example. So there is no thumb rule that we have to consider only 2 like that.
If you don't mind, can I ask one more question, sir?
Please, ma'am.
Yeah, that is in the function you mentioned one point. You are getting the information, your velocity is going to be updated, right?
Yes, ma'am.
So in your problem, you are taking the alpha 1, alpha 2, something like that. So that is, which is the velocity here? That is, what is the updated values in your inverter? Updated values means velocity. In the previous problem, you're considering the velocity.
Yeah.
But in this
Okay.
what is that?
So let us say if you take the numerical example, what is the updated velocity? After updated velocity, what we have calculated, updated position we have calculated. In the problem x minus 7 whole square problem, first we have calculated updated velocity, then we have updated the position. Similarly, in our case, what we will do is we will update the switching angles here. So that means angles will be updated here after calculating the velocity. So how we calculate the velocity? That velocity can be calculated by using that formula.
So whatever the values you are getting, that is between the 0 to 90.
0 to 90 degrees. Then it will be updated. Position will be updated.
And that is, what is a modulation index? That is, you are considering from 0.2 something, right? That is
actually for modulation, it will be varied from 0 to 1, ma'am. Over modulation index means above 1. But usually in all drive control, we will use modulation index 0.5 to 1. 0.5 to 1.
Okay, sir. Anyhow, it's a very informative and nice session. And thank you. Thank you, sir.
Thank you, ma'am.
Is there anyone still to ask questions to the Joshi Manohar sir?
So thank you, sir.
Okay, sir. Thank you, sir, for giving such a good explanation. And the session was very informative. And you explained even very difficult topic also with practical examples, which was frequently coming in our life. So on behalf of CREC faculty and participants, I thank our resource person, Dr. V. Joshi Manohar, sir. We are really enlightened with your knowledge and presence. Thank you, sir. Thank you very much, sir.
Thank you, ma'am. Thank you once again for all the team members for organizing the good event. Thank you once again.
Thank you, sir.
Right.
Hello, sir. Yes, sir. Hello.
Sir, tell me, sir. Hello.
Yes, thank you, everybody. The session has been completed. So the feedback and the attendance session has been shared in the WhatsApp groups. So you can leave the meeting. Thank you all.
Sir, may I speak to Srinivasan KG, sir? Sir, Srinivasan KG is available in the online in the meeting. Sir, please respond, Srinivasan KG. Sir, Srinivasan KG, Srinivasan sir.